we go. Okay, so this is going to be, I hope, the last part of section 11-1, and I'm going to introduce two things in this. Only one more inference procedure. Okay, but before we start, I want to get something out of the way. When you're doing a two-sample t-test on your calculator, one of the choices that you have to make is there's a thing that says either pooled or a non-pooled. Okay, let me tell you something. Always choose no pooled. Okay. The pooled t-test works great if we know for sure that the variability in each population is the same. Okay, so the standard deviation of each population would be the same. We almost never have a reason to believe that, so just never choose the pooled t-test. Okay, just the two-sample t-test. Okay, so in this, we're going to do another inference procedure. But before we begin the inference procedure, I want to introduce something else. Remember, in the last video, I said that one of the assumptions we have to make is that the two samples are independently chosen from their respective populations. There is another way to set up a two-sample t-test as well, and that is when you select a group of people. It doesn't even have to be at random. Let's say you selected 200 people to participate in your study, okay? And they can even be volunteers with what we're going to do here, okay? And what you do, though, is then you randomly assign those 200 people to two different treatments, okay? So instead of randomly selecting a group of people from this population and randomly selecting a group of people from this other population, we just get a group of volunteers, okay? And then we randomly assign them to treatments. Like what we might do is we might randomly assign 100 of the people to get drug number 1, and then randomly select, well, I guess the other 100 people would automatically then get drug number 2. And then, you measure the difference in the mean cholesterol reduction, for example, within the two, among the two groups, okay? So that's another way that you can legitimately set up a two-sample t-test. Now, we are going to do that in this next example, but we're also not going to do a two-sample t-test. We're going to do the two-sample t-interval. Okay, so this is the inference procedure in this video is going to be called the two-sample t-interval. Okay, and that is exactly what it's called on your borrowed calculators as well. Okay, so you start out the same way you do with a two-sample t-test by defining the parameters of interest. Now, the example that we're going to do right here, let me get to it a second here. Sorry. Okay, what's going to happen here is we are going to select a group of people, and then we are going to assign them to two groups. One group is going to wear a fitness tracker, and another group is not going to wear a fitness tracker, and we're going to measure the collective weight loss, the mean weight loss in each group. Okay, so we're not randomly selecting anybody here. We're getting some volunteers, and we're going to randomly assign them to either the group that wears a fitness tracker or the group that does not. Okay, so let's begin. I'll define my parameters of interest. First of all, mu sub f will be the true mean weight loss for the tracker group. Okay, they're going to wear fitness trackers. And then mu sub n will be the true mean weight loss for the group that is not going to wear fitness trackers, for non-tracker group. Okay, so we set up the we define the parameters of interest the same way, and we could run a two-sample t-test here, but we're going to do a two-sample t-interval instead. Okay, so with a confidence interval, remember, we don't have to make hypothesis statements. Okay, we just go straight into it. And what I'm going to do here is I'm going to write down the sample statistics here. Let me get to them. All right, so it looks like the sample, X bar sub F is 5.90, and X bar sub N, the group without the fitness trackers, is 3.50. Okay. The sample size, the number of people in the groups, here N sub F is 170, N sub N is 181, and the standard deviations, let's see, S sub F is going to be 6.8, and S sub N is going to be 3.5. No, sorry, that was the sample mean. It is 6.3. Okay, so we've got that. On the next page here, I'm going to define the procedure that we're going to use. Although you can see it at the top of the board space. There. So I'm going to define I'm going to name the procedure. It's going to be a 2-sample T interval. Okay. Our conditions, okay, to check for the conditions. Well, it's the same as it was for a 2-sample T test. Okay. Now instead of saying that these were independently chosen random samples, though, this time, since they were randomly assigned to groups rather than chosen independently from their respective groups, we're going to say that these subjects were randomly assigned to treatments. Remember, this is really an experiment that we're doing here rather than an observational study, because the subjects were randomly assigned to either wear a fitness tracker or to not wear a fitness tracker. So that's our first assumption in this case. And then the second assumption has to do with normality of the sampling distributions. And since we were lucky enough to have large sample sizes, yet again, I'm going to write since, let's see, N sub F is greater than 30, and N sub N is greater than 30, we can assume normality of sampling distributions. Okay, so we have named our procedure and we have checked our conditions. Next one I'm going to do is I'm going to write out the formula for the confidence interval. Okay, let me get to it so I make sure I write it down correct. Whoops, I'm going the wrong way. Sorry, my computer is slightly slow. Okay, here we go. So I'll erase this and we'll write down the formula for the 2-sample T interval here. So it goes like this: X bar sub F minus X bar sub N plus or minus. Okay, so this is the point estimate of the difference between the two means. T critical value times the standard deviation of the test statistic. So the structure of the interval is the same as every other interval we've ever done. So that's S sub F squared over N sub F plus S sub N squared over N sub N. Okay, so that's the formula for the T interval. Now, to get your T critical value, you've got to calculate T, or no, excuse me, that was stupid. Well, what you do is you look it up in the table, okay, for what your chosen confidence level, and we'll choose a 95% confidence level. Now, I'm sure that everybody's doing this on a calculator, so I'm going to go ahead and put the values for this up here. Give me 1 second. Sorry. Now, if you want to do this on your calculator, go to a 2-sample t interval. Okay. So this is what the result is. So t is 3.42, which makes the p value 0.001. Okay, which makes our confidence interval. Okay, and I actually don't have to write down the p value here. I would have to if I was doing a 2-sample t test, but I don't necessarily have to. I wrote it down because it was on here. And then the confidence interval has boundaries 1.021 and 3.779. Okay, now let's talk about what this means. All right, we know how to interpret a confidence interval. Remember, I'll say it here. We're 95% confident that the true difference in mean weight reduction lies between this many pounds and this many pounds. Okay, again, we're 95% confident that the true difference in mean weight reductions is between here and here. Now, does that provide evidence that fitness trackers work? Well, if you look at this, the interval does not include 0. Okay, so 0 is not a plausible value for the mean or for the difference in the two means. Okay, so we would say that this does, well, we did find sufficient evidence here to conclude that the difference is something other than 0. In fact, that the difference is greater than 0. So, this study provides evidence that fitness trackers apparently work. Okay, now listen, the 11-1 assignment's on there. I'd like you to try it. You can email me with any questions. Thanks for watching. We'll see you when it's time for 11-2.